Hey guys, so we're gonna pick up where we left off from the last video, and we were last working on average rate problems. So we have another problem here today where the problem has to do with finding the average speed over a given time interval. So let's get right into this. So the problem reads, the position in feet of an object moving in a straight line is given by the function p of t equals t squared minus 1/2 t plus 7, where t is the time measured in seconds. What is the object's average speed over the time interval from 2 to 4? So we have a few answer choices over here. And what we're going to do is we're essentially going to use the same formula we used before, right? But in this context, we're using it to find the average speed. So average speed is defined as the distance divided by the time it took you to travel that distance. So in terms of math, right, we can write our V average is equal to the position at the final time, right, T2, minus the position at the initial time, T1, and then divided by the change in time, right? So this is the time it takes you to travel that distance, T2 minus T1. So in this case, our T2 would be 4, right? So we would have T2 equals 4, and our T1 will be 2. Now, our position function here, the S, is going to be represented by P of t, right? So we want P at T2, and then we also want P at T1. So in other words, we want P at 4 and P at 2. All right, so let's go ahead and calculate P at 4. So P at 4 is going to be 4 squared minus 1/2 times 4 plus 7. This gives us 16 minus 1/2 of 4, that's just 2, plus 7. And that gives us a total value of 16 plus 7 gives 23, minus 2 gives 21. Right, so P at 4 is equal to 21. So the next thing we need to do is evaluate P at t equals 2, right? So P at 2 is equal to 2 squared minus 1/2 times 2 plus 7. And this gives us 4 minus half of 2 is just 1 plus 7. So here we have 4 minus 1 is 3. Add the 7, we get 10. So P at 2 is equal to 10, right? So our average speed is nothing more than the distance traveled at T2, which is 4, minus the distance traveled at T1, which is 2, right? So we want 21 minus 10 divided by 4 minus 2. So our average speed is equal to 21 minus 10 divided by 4 minus 2. So this gives us 11 divided by 2, which we can write as a decimal, 5.5. So the answer here will be the last answer choice, 5.5. Okay, so the next problem we have here, it says Gary drives his car from San Francisco to Los Angeles, a total distance of 400 miles, leaving at 9:30 a.m. and arriving at 2:15 p.m. the same day. What is his average speed in miles per hour? So we have the average speed formula here again. I've just written it a little bit different. And I've written it here as delta S, right, which is the distance traveled, divided by delta T, the change in time. So delta represents a change in a certain quantity. In this case, change in position, change in time. So we work this problem the same way, right? The first time that we have is 9:30 a.m. and the second time we have here is 2:15 p.m. So delta T is just the change in these two times, right? So from 9:30 a.m. to 2:15 is a total change in time of 4 hours and 45 minutes. So it's important to notice that this problem asks us to get the average speed in miles per hour, right? So we already know that he traveled a distance of 400 miles, right? But now we need to know the total amount of hours that he traveled, right? Our change in time here is 4 hours and 45 minutes. And since it takes 60 minutes to make 1 hour, we can convert the 45 minutes into units of hours. We can write 45 minutes, and 1 minute is just 1/60th of an hour. So we can write this as 45 times 1 divided by 60 hours, right? So 45 over 60 is just 0.75. So this is 0.75 hours, which means that the total change in time is 4 hours plus this extra 0.75 hours, right? So delta T is equal to 4.75 hours. So since we have the change in time now, we can just calculate our average speed as 400 miles divided by 4.75 hours. So that means our V average is just 400 divided by 4.75, and the units will be in miles per hour. And this comes out to be 84.21 miles per hour. So our closest choice here would be the second choice, 84.